Good morning, good evening, and welcome to NetRadar Webinar Mobile Network Crowdsourcing 2.0. My name is Tomi Paatsila. I'm the CEO and co-founder of NetRadar, and here joined two of my colleagues.
So my name is Jukka. I'm the co-founder and CTO for NetRadar.
Yes, my name is Jukka Hieta. I am sales director in this company.
First, a couple of householding matters. Webinar presentations will last for roughly 30 minutes, followed by a Q&A session. You may post your questions on the right-hand side on the chat box of your screen. Today, our presenters will go through how leading mobile network operators are bringing customers into their decision-making to improve their services. High-level benchmarking data is simply not enough for this, and this is exactly where NetRadar can help you. Typically, network-based tools are often sufficient for building a decent network, but only with the customer data you can build a truly competitive advantage for yourself. We do not sell you third-party data, but instead we have an end-to-end solution which allows telecom operators to collect huge amount of performance data as your users are using the services. Data collection happens with the NetRadar SDK, which is activated in operators' own subscription management, customer care, or media apps. As the users are consuming data through any types of applications, apps, anonymous performance data gets collected in the telecom operator's private cloud environment or their own data center. Furthermore, Jukka Hieta will be going through an example of NetRadar's dashboard, which is the visualization tool for the data itself. As the foundations of NetRadar do come from years of research done at the Finland's Aalto University, who would be the better person to present the mobile network crowdsourcing 2.0 than Professor Jukka Manner, our CTO and co-founder. Jukka, please.
So good morning, good afternoon, good evening from my side also. So let's go shortly into the technology behind NetRadar. So as Tomi mentioned, NetRadar is based on 10 plus years of research at Aalto University. And it has been a long road. And as researchers, so as our foundation is from research, we didn't need to care how things were done in the past, what the legacy is, and how people are used to doing things. But we could redesign how crowdsourced network performance data should be actually collected. So what makes sense and how it's best done given the freedom that we could invent everything and anything. So in that sense, I ask you to hopefully forget what other things are doing today, how you have used to seeing crowdsourced data being collected, because we have done things totally differently. Now, back in the days when we were developing crowdsourced data collection, that we had certain design goals in mind. First of all, as researchers, we of course needed to maximize the amount of data. So the more data you have, the more details and in-depth analysis you can do, and the less variation there is in the results, so you can trust the analysis much more when you have a lot of that data. Still, with the data, having a lot of data is kind of useless if you cannot trust your data. So if it's not accurate and useful, and in that sense, you can with good confidence do analysis of that data. So if you have question marks on what the data actually tells and what it doesn't, it will kind of break your analysis and the results. And then when we are talking about crowdsourced data collection, and now we're talking about data collection together with consumers, with ordinary citizens, then the technology must be such that it doesn't impact the consumer. For example, it doesn't eat a lot of data. It doesn't, by that way harm the user's data plans. But at the same time, even with unlimited data plans, you cannot be consuming a lot of energy and creating load on the device. So it has to be as conservative and passive as possible, but still provide a lot of, good data. If you look at currently the market, existing solutions can provide maybe one or two of the above, but none can really solve these three challenges. So you can get a lot of data, but you cannot really trust it with certain solutions. With other solutions, you can get accurate data, but then you don't get a lot of it, and it might actually be impacting the user a lot. So at the end of the day, it's not really beneficial. So if you quickly summarize existing approaches that most of you are used to seeing, then on one hand, you can read passively radio values, which of course gives you a lot of data on radio data, but then the radio data doesn't really answer the question of how well does the bit rate flow to the user. A good signal is of course a minimum requirement, but it doesn't highlight, for example, network congestion, or it doesn't highlight, for example, issues in the cloud services. You could also read passively bit rate, what the user is getting on the device, what type of speeds. But then the question is, why did the user get a certain speed? You see the user, for example, getting a 10 megabits of peak download speed. Why was it 10? Is it because the network is limiting the user bit rate? Is it the cloud service limiting the user bit rate? You don't know. So it's very difficult to use that type of data, because you don't know the reason for the speed. And on one hand, of course, you have a lot of these apps and services where you press a button and do a speed test. Of course, the good side is that that's a systematic approach, so you can systematically measure the top speed of the network. However, the question is that, of course, it gives you the top speed of the network at a certain point in time, and aggregating that will not give you a lot of data. And then it, of course, has a huge overhead on the consumer. So yes, trustworthy data, but so little that what you can do is pretty much just country level benchmarks, and that's about it. You could also run speed tests in the background, so have some mechanism which runs automatically speed tests like once a week, once a month, and so forth, which of course gives you more speed samples. But then the question is about the overhead and the usefulness. So if you run these full speed, heavy tests, then of course they create overhead on the consumer without the consumer knowing. And if you do very lightweight tests, speed tests, then you might not be saturating the network, so you don't actually know whether you can trust the results. If you have run a background speed test that gives you 10 megabits of peak speed, was it again because the test ended or because the network was loaded and only allowed 10 megabits? So you don't know. So if I try to summarize these by using two axes, on one hand, looking at geographic distribution of the usefulness of data, and then on one hand, time axis. Then these solutions where you are pressing a button pretty much give you a country level yearly comparison of operators. Who is the fastest operator in the country, which is nice for marketing purposes, who is the fastest, but that's about it. You cannot use that data to actually make meaningful changes to your network because there's not enough data, and so it's useless. You could do various background speed tests, which of course extends your horizon. Maybe you could even do county level comparisons, even city level comparisons, but even there it's limited to yearly, maybe quarterly level. You cannot, even that data you cannot use to actually make meaningful changes to your network and enhance the network. Of course, then you can do different drive-through testings and walk testing solutions where you get a very detailed snapshot of a radio and speed of a certain narrow location or street or building, but only for an hour or a minute of when the test was done. You don't know what the service was last week, last month. You don't see the trends and so forth, and you get only a very limited snapshot. So of course, then the question is, what does NetRadar tackle in these axes? So what are our use cases? Well, we cover all of them. We can look at cell sector level, daily studies, even on cell sector frequency range. We can look at CDs on a daily basis, weekly basis, even country level comparisons. So we can do basically any combination of these with the data. that we are collecting. So in the next few slides, we'll highlight how we do our magic and what is the methodology behind our innovations at the Aalto University. So at the heart, we have the user. And the user is using various apps on a daily basis. Of course, youngsters have different apps than potentially business people, and those who are heavy gamers have different apps. So of course, the apps differ on a user level. But the commonality is that all these apps are actually generating traffic to their respective cloud service. So they are sending and receiving data. For us, this is the measurement payload. We never do synthetic speed measurements, never. We study the user's own data streams and where the user is using data, how much, and so forth. And we can do very detailed analysis on that part. The only things that our system generates in terms of data is we do latency measurements, so-called pings. So we measure the latency variation, jitters, and stuff like that. So very small IP packets are always tied to the data traffic. And of course, we are uploading the results from time to time to the backend. Can be uploaded every hour, once per day, depending on a configuration. It can be uploaded also only on Wi-Fi, so minimizing even that impact on the cellular network. And we calculated that on typical use cases, all overhead of running 24/7 analysis on the user's connectivity introduces 1% or even less of overhead. So it's very lightweight, considering that you get a 24/7 view of users' connectivity. Now, in terms of using the data, then it can be deployed in a private cloud, in a public cloud, on virtual machines, or bare bones systems, depending on your wishes. So note that, as Tomi mentioned, we don't sell data; we send the world's top technology to do crowdsourcing. We have a dashboard that Jukka will be showing later on today of key metrics. But the point here is that it's your data, so you get full access to that data. You can decide who gets used to it, how many people in your company get used to it, where you want to use it, how long you want to retain the data, and so forth. You can integrate with third-party analytics tools and so forth. So note that it's yours. It's not something that is given to your competitors. It's your data. So you get to do whatever you want with it. In terms of KPIs, so we collect a lot of different things. We look at the speeds, not simply top speed, but also averages, variations, bytes, packets. We look at how long people are transmitting data. Of course, when they are doing that, we are measuring latency, minimums, maximums, variations, jitters, both on uplink and downlink separately. We study network congestion, and I'll brief you in a moment what the network congestion here means, because that's the key in our innovation. Of course, we know where the user was then using the data, what the cellular technology, all the radio details you can think of, we have them. And we even have a new methodology to study how deep indoors or outdoors the user was. To have an understanding, for example, if the user has a bad radio connectivity, was the user in the basement or in a garage? Last time I checked, we had 274 KPIs in our data model. So rather extensive, and I think it grows almost monthly. We invent new things. So how does the NetRadar hybrid tech work itself? So as mentioned, we use the consumer's data as the measurement payload. So we never do synthetic speed test and waste energy and data that the user needs to cover for. So we measure the latency and the latency variation together with the consumer's own traffic, not outside of it, but together and inside the data flows. We collect, at the same time, we collect these speed metrics, averages, maximums, how much data is flowing, all those radio details, locations, you name it. And through that, we can build various maps, trends, looking at individual base stations. We can even automatically pinpoint missing coverage and larger problem areas with the anomaly detector that you will be seeing in a few moments. So this is what the users, your consumers, customers are seeing, not what the theoretical models say, but what the reality is in the field. And the big thing here is that our proprietary algorithms can calculate the level of congestion in a network. So for example, if the user is getting 10 megabits of peak download speed, we can know whether it was because of the network or because the cloud service was just sending very low bit rate. We know, no one else has that. Then before I stop and give the other Jukka the floor, one slide about the service level score. So SLS is a metric purely from NetRadar and is only available because it's our technology. Now, since we know what speeds users really are needing, because we are monitoring the users' daily bitrate needs, and because we are monitoring the latency and latency variation, we see abnormal behavior in the latency. And we see when the network starts to be congested. So when latency starts growing and start behaving erratically, we know that the network is not fully functioning. So the SLS is in all its simplicity, is a metric telling how often people are fully served by the network. So when everything is fine, then how often the network really works well. And the low SLS means that the services and apps that users are using are very often or too often slowed down by your network, so implying a very bad user experience, and the apps will not be working well. The beauty of the SLS is that it's not tied to specific magic numbers, but it basically adapts to different markets. And in that sense, if you have markets where you have limited data plans, people are using less data, and we have markets where you have unlimited data plans, people are using heavier apps and much more data. So actually, SLS adapts purely and totally to different markets. But this is in short the technology background. Then I'll let Jukka to introduce you to the dashboard and the NetRadar technology benefits.
Yes, hello from my side as well. And like Jukka already said, I will be showing you NetRadar main benefits, some of our use cases, and also our visual dashboard. So we are really collecting huge amount of data, and this takes us apart from our competition. We can gather even 10,000 times more measurement data for the operator to then so that they can optimize their networks. And we are putting customer in the focus, so the data reflects how the customer is really experiencing the mobile network. We can analyze capacity constraints and other KPIs in all of these mobile technologies, 2G, 3G, 4G, 5G, both non-standalone and standalone networks, and even fixed internet service providers, meaning that Wi-Fi traffic can be analyzed as well, if so wanted. It's also possible to see the indoor and outdoor location of the person with further analysis. This is very useful if there's a congestion to know the actual location of the person who is experiencing this. And we will be showing you our anomaly detector later on as part of our visual dashboard. It is showing automatically bigger challenges for the operator that might need very rapid fixing. And it's good to remember that operator is owning this data 100%. I'm not going to go through all of these use cases, but just to pick up a few, maybe the most important ones. So really operator can do proactive network performance analysis before the problems are even emerging. This is important to keep customers satisfied and to prevent churn. With our solution, with the visual dashboard, you can analyze even the cell sectors and their effective coverage and capacity and the capacity constraints. So our solution really is replacing the tedious and expensive drive testing. And with our solution, you can even isolate application issues from network issues so that operator can make optimal decisions. So some words about the dashboard. It's just a demonstration environment with some thousands of friendly users that we have with all of the 3 main operators in Finland. In the real commercial environment, there would be hundreds of thousands or even millions of users, depending on the size of the operator. You will, in the next slide, or in the next part of my presentation, you will see Finland overall situation with all of these 3 different operators. I will show you how to drill down even to the cell level in the mobile network. And then I will also show our anomaly detector. I will use a service level score related problems as an example. So I will now switch to our dashboard, and it might take some time so that before it will actually come up to the screen, depending on the size of your network, or the speed of your network. So it might take some time. It's now downloading or uploading, so depending on your network connection, it will come up. So here you can see overall Finland with different colors. There's a legend down below. So difference to average signal quality. So there's a color code there. And I can choose, for instance, now I will go a bit closer. I will choose Uusimaa region. Helsinki, as you can see, the capital Helsinki is located there. So there are the most people there. And here on the right side of the screen or display, you can see in different months what has been the downlink speed. But actually here you can see the network maximum speed, and here with figures you can see the downlink average, uplink average, network speeds, user speeds, so that the user has been getting both on the downlink and the uplink. And you can also see upload analysis, and here you can choose a respective area that you want to analyze. Turku is the second biggest city in that Varsinais-Suomi county. So there are different variables that you can then analyze and see, even on the graphical format. Geographic distribution of speed can be seen on percentages, and then probability of speed as well. Then I will show you our network view. So here I can search a particular address. I will choose Kluuvi, which is in downtown Helsinki. So we can select a specific tile here, and then you can see different variables on that particular tile. Size of the tile is about 100 by 100 meters. You can see signal strength, signal quality, signal to noise ratio, both constrained and unconstrained speeds, on download and upload directions. You can see the service level score. So on this particular tile in very downtown Helsinki, 93% of the users have gotten the service that they have requested. And we can also analyze base stations. By the way, here you can see all the base stations that are serving this particular tile that I have selected here. And if it's green, then everything is okay. So constraint speed, both downlink, uplink direction is fine. If it's an orange base station, then there is problem either on downlink or uplink. And if it's a red, then there is problem both on the uplink and downlink. And here I can choose time frame as well. I will show you the base station view. Here you can see base stations. Number 4 here means that there are a group of 4 base stations. I can select a base station to be analyzed. You can see the area that this base station is serving. And then you get certain variables on that particular base station. So download and upload, constrained and unconstrained speeds. You can see the location area code of that particular base station and base station ID as well, and used frequencies and cells. Okay, I will then show last anomaly detector. So you can check anomalies based either on coverage, service level score 10, which means that the user has been getting either at least 10 megabytes or then the service that he or she was requesting, or we could analyze indoor-based anomalies problems. But I will choose now service level score related problems. There are 144 anomalies found in 63 cities. I can filter by city. So let's choose Turku, which is the second biggest city. I can choose the anomaly that I want to analyze. I can change the satellite view, and this happens to be Turku harbor area. So there are ferries going to Sweden, for instance, from Turku harbor. So there might be at certain times of the day, there are lots of people there. I chose this particular cell here, and you can see that the service level score is only 51%. So it is actually very bad. So there is problem with this particular operator, and they, of course, want to do something for that problem. Okay, so that was our dashboard. So I leave it here. And of course, we would like to do pilots with you. It's very simple to do a pilot with us. You would get full access to raw data generated by some maybe 10 to 20 friendly users that you would be choosing from your organization. And the results, measurement data is stored in the cloud, only available for you. You would get a trial version of our dashboard. And so you could get visually see the data that is generated and the results. And then, of course, you would get a workshop with our CTO in the end of the trial if you want. Usually the trial lasts 2 to 3 weeks. So please contact me for a pilot. If you are looking at this, watching this webinar from your desktop or laptop, there is a Calendly link in the end of this webinar where you can book a session with me. Or if you are on mobile, then you can go to our website and book a session with me easily from there.